All right, so Marco is here to have a chat about images. Yeah, kind of? All right. So give a big round of applause for Marco, our last talk of the evening. Go.
Thank you. So thank you everyone for coming. And I know this is the last talk of the day, so I'll try to be as light, as quick as possible, so we can all go and drink. So first of all, I'd like to say that this is my first talk ever, so I'd like to thank the organizers of this amazing event, PyCon Balkan, for giving me the chance to be here today. So thank you. And so my name is Marco, and I work at Hippo. Hippo is a small consultancy company. We're a fully distributed team, so we're all kind of around the world. And you can find everything you need to know about me, well, only what I want to share, here on hacandstack.com. This is my Twitter handle, so feel free to contact me for any question or whatever you want. So, how many of you know Rick and Morty? Amazing. Okay, this is going to be an amazing talk. Cool. So the thing is, I don't want to share details about my client, right? Our client. So I decided to turn this into a Rick and Morty episode. I took an existing episode and I changed a few things. So if you're a fan, I'm sorry, you're going to be disappointed. If you're not a fan, if you don't watch the show, shame on you, you should. So for those of you who don't know, this is Rick Sanchez. He's a crazy scientist who basically has the ability, he's the smartest guy in the universe, allegedly. And according to him, he's God. And he has the power of traveling around the universe and traveling between dimensions, right? So the problem is one day, he comes back home, and his family home is invaded with a bunch of parasite aliens. Now, these aliens have a special ability. They can inject false memories into humans' minds. And so they make you believe that they are your friend, your coworker, your family member, and so they can blend in with the rest of the humankind and take over the planet. Now, the problem is Rick is aware of the presence of these aliens, but he doesn't know which ones are the aliens and which ones are the family members. So here we have the other family members, Morty, Jerry, Beth, and Summer. Okay? Amazing show. So he comes up with an idea. By the way, Rick is me, if you didn't understand. Yeah. So he comes up with an idea. He wants to train basically a machine learning model, a classifier, with a bunch of images of these aliens. So he collected a lot of data sets throughout the years in his explorations, and he wants to train a classifier to be able to recognize which ones are the aliens and which ones are not. So he understands that one very good feature, one good indicator of whether these are aliens or not, is the dominant color of the picture. Now, computing the dominant color is not trivial. There are a few algorithms. This one is called the K-mean clustering algorithm. I won't go into detail, but basically what it does is it recursively creates clusters of pixels by averaging their color. And you can find here an example with 3 clusters, and these are the 3 dominant colors. In our case, it's only 1. And this is a sample dataset item. So we have a bunch of metadata. We have the ID of the item, not of the image, the name, the height of this particular alien, and a bunch of images, right? As you can see, the images are stored on S3. Keep this in mind. So Rick starts working on the first version of this thing, and he comes up with this solution. So this is a very simple function. He's deploying this on some EC2 instance and just running it on all the images, right? So he wants to get the dominant color from an item. He iterates over all the images. He retrieves the image from the S3 bucket. He computes the dominant color because you need the actual data of the image. And then he stores the image to another S3 bucket, a bucket that we control. Because obviously we can't rely on third-party buckets, right? What if they delete the data? Now, the classifier works in the cloud. So we have to post this stuff to a web API. And that's why you have a post request here. This thing is working perfectly well. There are a few thousand items that we have to process. It's going to take a few hours. It's basically processing 1, 2, maybe 3 images per second. And so, like any other good programmer, Rick kind of goes to the pub and drowns himself in rainbow-flavored beer. The problem is, the next day, he wakes up to terrible, terrible news. The data sets have multiplied. Rick has clones. in many dimensions, in many universes, and they all brought their own data sets. Now, he needs to process not tens of thousands, but tens of millions of images. And obviously, going with 1 to 2 images per second is not a viable solution. And OK, the true story is that the client basically told us, OK, we don't have time for this, so please come up with a faster solution. OK, cool. So what he starts doing is the typical optimization, right? So he fires up a profiler, he figures out which parts of the code are slow, he optimizes everything, and he quickly realizes that the bottleneck is the network. So the thing is, we have to retrieve an image, then we have to process it, and then we have to store it to another S3 bucket. That's very time-consuming. The obvious solution to this process, to this problem, is parallelizing, right? So we want to take advantage of concurrency to make sure that we can process all of these images in parallel and speed things up like 10 times. Now, this brings a few questions. First of all, we have to decide whether the workload should be split among processes or among machines, so we have to decide which level of abstraction we want to use, right? And of course, we're limited by the amount of workers, so we'll call them workers. Processes, machines, doesn't matter. The amount of workers that can be spawned. And how cost-effective is it to spawn n machines versus a bigger one? What if the one we spawn is not enough? Should we set up auto-scaling? What if the number of datasets doubles, and it did? How do we divide the workload among the workers? And what happens if mid-workload we add a new worker? What happens if one of the workers fails? We need a way to redistribute the workload to other workers, but that probably means we have to implement a priority queue, and then the workers have to pick their next batch. What if the priority queue fails? I'm lazy, OK? I really don't want to deal with all this stuff. Please. Concurrency is hell if handled incorrectly. And it's very likely that we'll handle it incorrectly. So the thing is, that's a ton of code to write. And even if you did manage to write this much code, there is another slight problem here. This is an amazing talk by Greg Wilson. It's called What We Actually Know About Software Development and Why We Believe It's True. And basically, the claim is that we kind of removed the word science from computer science. So nowadays, we kind of base our decisions on trends and opinions rather than data. So he has the case of agile methods, right? Everyone wants to use agile methods. But there is no data that supports the claim that agile methods are actually faster than the traditional waterfall method. There is absolutely no study that proves this, and yet, here we are. He also, so at minute 40, he cites a study. I have to read the title because obviously I don't remember it. So if I do this, it's going to change. Yeah, sorry. This is a bit... Stop. OK, I lost it. Whatever, I'll share it later with you. It has a very, very long title. But basically, the purpose of this study is to prove that all of the previous studies about understanding complexity in a code base and predicting how many bugs that code base will have boils down to one thing. Doesn't matter which language you're using, doesn't matter whether you're using frameworks, libraries, if you're a great programmer, it's the number of lines of code. That's the only metrics that counts. It's the only indicator, well, not the only, but it's the best indicator of a buggy code base. And when I mean lines of code, I mean literally WC-L. That will tell you how many bugs your code base will likely have. Okay, so there is a scientific proof that we want to write less code. Obviously, the best code is the one that never gets written. We all know that. Jerry isn't a particularly brilliant guy, but one day he's having this talk with Rick, and he comes up with this idea. You see, the images are stored on S3, and we are moving them, we're copying them to another S3 bucket. Can't we just, offload the network to Amazon? I mean, that's what they do. Why do we have to retrieve the image and then move it back to another S3 bucket? That's stupid. The problem is we have to process the image, and there is no way to store metadata in S3. So we have to literally take the whole image, process it, and then store it. But But this is how our current architecture looks like. So we have an EC2 instance. We have this function running get dominant color, and it calls the API, and it does the moving between buckets, the copying between buckets. What if there was a way to extract this function, connect the two S3 buckets directly so that we don't act as an intermediary, and batch copy all the images? And every time an image is copied, we simply process it, and we make the call to the API. Well, turns out there is a... OK, let's be realistic. There is a way to do this, and it's called AWS Lambda. Now, this thing is really, really powerful. So the first thing we want to do is to set up a Lambda function that is triggered by an S3 event. In this case, it's an upload of a file, right? Now, Amazon offers these blueprints, so you can easily take one and just customize it for your needs, okay? It's very easy. You no need for all these libraries and frameworks. Those are useful if you want to host like a whole service on Lambda. But I feel like this is a better use case for Lambda than many, many others. There is a problem. Lambda only provides, for Python, Node.js, access to the AWS services natively. So the libraries you can access, they're basically the ones used in AWS. If you want to use another library like Pillow for image processing, there is no way to do it easily. So what you need to do is to create this called thing, the deployment package. So basically, you go on a Linux machine, you install the virtual environment, you install all of your requirements, you zip the whole environment with your code in it, and you upload it to AWS Lambda. That's it. It's not complicated, but there is a nice guide here. Then what you need to do is to set up the trigger properly. You can prefix the trigger so that only images in one specific folder inside the bucket will trigger this Lambda function. And for the love of God, don't forget to set up CloudWatch logs and notifications, because this thing will likely fail. Okay, so you want to know. Okay, I'll tell you a very brief digression. There was an error in the first version of this thing, and I actually set up SNS and SES to email me for each and every error. Can you guess how many emails I received in one day? Yeah, like tens of thousands. There is no way to stop an email from coming in Gmail. Okay, I know this for experience. It's really painful. This is what the simplified code looks like. So we have a Lambda handler on the left. And the thing is, you want to test this locally, right? So how do you do it? Well, you can mock the Lambda event by simply mocking the event object. So you have these event and context arguments. Context is most of the time not entirely useful. Event is the one that matters. And so here you have a sample. I'm not going through the whole code, but what I did was I put some test images on an S3 bucket for testing, and then I simulated the concurrency by using multiple processes, right? So each process kind of triggers this, it calls this function with a given path to the image. Can you guess why I used processes? Why not test one image after the other? Can anyone guess? Sorry? No, these are processes, not threads. No. I mean, yeah, okay, that's the thing, but no. Not really. The thing is, you want to test for race conditions, okay? This is something really important. This thing is going to run in parallel. So maybe this is not the best case, but in your case, you might have problems because you run into race conditions and you want to prevent that. And the only way is to actually simulate the concurrency. Well, this is not simulated, this is actual concurrency. This is what our current architecture looks like. So we batch copy images between buckets using the AWS command line utility, or there are many, many other ways. Each one of them triggers a Lambda function, and the Lambda function does all the processing and calls the API. Great. You don't want, second mistake, you don't want your Lambda function to hit your API arbitrarily. Okay? You don't want hundreds of thousands of Lambda functions hitting your API like there is no tomorrow. you want to buffer this. And to buffer this, you can do it, well, there are many ways. We use DynamoDB. So basically what the Lambda function is, it actually writes this metadata to DynamoDB, and then we retrieve the stuff from DynamoDB, which is a lot faster than actually processing the image, and we make the calls from a separate worker. Then, of course, this can be scaled with an arbitrary number of workers. So a few warnings. First of all, make sure you give enough timeout to your Lambda function. Initially, this was failing because, yes, there are images that took more than 3 minutes to process. I don't know why. You can't really easily profile a Lambda function, but I don't care. That's the thing. Like, sure, it might be a bit more expensive for the client, but we have the, like, how do you say? We have permission to do it, so that's fine. And also, it has to have enough memory. The other thing you have to be careful about is, if you're using DynamoDB, is to give enough write and read capacity. Now, this is the number of concurrent reads and writes. These are not real numbers. Ours are much, much higher. And it's going to be a bit more expensive. So when you're done, you either set up auto-scaling, or when you're done with the processing, you bring the numbers down. Otherwise, your bill is going to go to the stars. There is also a notification so that I get notified if there's a problem with DynamoDB. And these are some metrics. So as you can see, we hit. So every hour, CloudWatch logs the number of calls to your Lambda function. In that case, you can see we reached 320,000 calls in 1 hour. That's roughly 90 images per second. Now we're processing. This is not just the dominant caller. Okay, we're doing a lot more stuff. 90 times a second. Now for comparison, your phone records at 60 frames per second, unless you have like a flagship with a nice camera. And then you have a lot of other metrics. The errors that you can see here, they're not because this thing is failing, because it's incredibly reliable. It never failed once it was correct. It's because some files are either corrupt or they're not actual images. So there's nothing we can do about that. Okay, so we're done with the task. We're happily killing all these stupid parasite aliens, and the family is finally free of this threat. But the takeaway from this talk is that nowadays, developers, we have a lot of power. 10 years ago, this would have been unthinkable, that one developer could set up an easy system, a simple system, and have this amount of parallelization, right? And this is nothing. I mean, there are people doing much, much worse. So we should appreciate this. We have the power in our hands to be just a single developer and be able to literally set up these incredible infrastructures. I think this is a great achievement, and we should appreciate that. So yeah, now we're all happy, the aliens are gone, and you know my story. Thank you.
Where are you going? Where?
No, I was reading the...
Okay. You can also do it behind you, if it's a bit bigger.
So if you consider using AWS Chalice with Lambda Handler option framework for building and deploying Lambda packages to AWS, I have to admit I'm not familiar with AWS Chalice, but if this is an easier way to set up Lambda functions, we didn't need to. There are many other ways. I don't know if you know Zappa, for example. Zappa is a very interesting framework, yeah. So yeah, I love that. Have you noticed any increase in number of errors, failed Lambda requests with increase of the load? No. That's the nice thing about Lambda. Even though like the average is like 150, 200,000 requests per hour, triggers per hour, when we reach the peaks, we never experience any error. No, it's very reliable. Do you have an estimate of price difference? No, I don't. I mean, I do, but this particular case, Lambda is cheaper for a series of reasons that I didn't mention in this talk. You don't just have to, so the thing is, you shouldn't take into account the price of the hardware, you should take into account how much time are you going to waste on this thing. Because a good developer's time is way more valuable than a few $100s you throw at Lambda or whatever other service you use. At least that's my argument. Okay, I think we're done.
We still have 10 minutes. If there's any question from the audience, maybe.
I kept it short, so.
Yeah, you can raise your hand and I'm gonna run. No? Well, yeah, okay. There you go.
Thank you. How many times did DynamoDB crap out on you? I know, because I hate it with passion.
We did have some problems in the past. I think it was related to pagination. It was in a different project because it doesn't tell you, okay, these are not all the results you have to paginate. At least it didn't at the time. No, to be honest, no, because we're mainly using it as a permanent key value store. So not, we never experienced any problem so far. Excuse me?
Are you using the temporal tables?
No. Temporal table? No.
Then you don't have a problem.
Yeah, probably. No, because we need to be able to access this in like multiple contexts.
Okay, any more questions? Or are we gonna call it a wrap for today? 3, 2, whoa, question, very far away question. Okay, let's do it.
How different is the process from Lambda when you compare, like, what can't you simulate in a process that Lambda can do? And more important, how do you debug it?
So the obvious thing is that you can't generate the same amount of concurrent processes that Lambda would generate. So if your workload is dependent on the, if your code is dependent on the workload, that's tough. But I don't really see a case at the moment. And how do you, the second question was, how do you reproduce it or debug it, sorry.
Debug
it. That's a good question, actually. Because the thing is, like I said, if it doesn't depend on the workload, then the same, and as long as you touch all the corner cases you have in Lambda, then the debugging is the same. If you think there are corner cases that you haven't considered because they only happen in Lambda, which I can't think of at the moment, but I want to give you the benefit of the doubt, then tough luck. Unless you want to buy AWS and like run your tests.
Okay, is it a wrap? 3, 2, take 1, take 2, 2, 3. Okay, it's a wrap. Thank you very much.
Thank you. So I decided to join PyCon Balkan 2018 because it was the first edition of a conference, and it was my very first talk, and it was in a place that I visited for the first time. So I think it's pretty obvious. I love it.